Let's jump right into this explainer. Kubernetes? If you're diving into container orchestration, it can feel like a total maze of technical jargon. But what if I told you it actually operates exactly like a highly organized, automated manufacturing plant? We're going to demystify Kubernetes architecture today by taking a tour of this factory. It's going to make perfect sense.
Here's our roadmap for the tour. First, the pod. Then, the architecture split. After that, we'll meet the master node supervisors, down to the worker node employees, and finally, we'll walk through the deployment workflow.
Okay, part 1, the pod. Before we meet the factory team, we really need to know what they're actually building on the assembly line. Every factory needs a product, right? Well, in Kubernetes, that product is the pod. Now, you might be wondering, why not just manage the containers directly? Well, think of a pod as a shipping box. It's the absolute baseline wrapper we're dealing with. Inside this box, you can pack one or more containers, and because they're literally living in the exact same box, they seamlessly share the same network and storage. Managing thousands of bare containers by hand? Total nightmare, pure chaos. The pod neatly packages them up so our factory can actually handle them.
Moving right along to part 2, the architecture split.
Now that we know what we're building, let's meet the two distinct teams making it happen. The system is split perfectly into a master and worker node architecture, which brilliantly illustrates the core dynamic of our factory. On one side, you've got the master node. Think of them as the management team, the supervisors. On the flip side, we have the worker nodes. These are your execution team, the employees on the floor. The master node handles operations and makes all those high-level decisions, while the worker nodes, they're out there doing the actual heavy lifting to run the pods.
But check out this quote from our source material. It says, if the master node goes down, we cannot perform any actions in the cluster. This really emphasizes just how absolutely critical the management team is. The master node is literally the beating heart of the whole operation. If it disappears, the entire factory just grinds to a halt. Sure, the workers might still be holding whatever they were last working on, but absolutely no new orders are coming in.
Which brings us to part 3, master node supervisors.
Since management is that vital, let's head up to the executive suite. We're going to meet the 4 specific supervisors that make up the control plane. What's really cool here is how each of these abstract technical terms maps directly to a familiar management role. First up, the Kube API server. This is our front desk receptionist. Anyone trying to do anything in the cluster, they got to talk to the API server first for authentication. Next is the Kube scheduler, our resource allocator. It decides exactly which worker node is the healthiest and best fit for a new pod. Then, the Kube controller manager. That's our floor manager. And finally, etcd. Now this isn't a person, it's the company record book. It's a highly secure database storing every single piece of information about the factory.
Let's take a closer look at our floor manager, the Kube controller manager. You can think of this as the true brain of the operation. It's constantly pacing the factory floor, making sure reality actually matches our blueprints. And it uses sub-managers to do this. The node controller is constantly monitoring the health of the worker nodes. Then you've got the replication controller, which ensures the exact desired number of pods are always up and running. If a pod gets damaged or sick, the replication controller is instantly responsible for recreating it. It is literally ultimate quality control.
All right, part 4, worker node employees.
Management is introduced, so it's time to put on our hard hats and head down to the factory floor. Here we meet the workers, the components actually running on the worker nodes. First is the kubelet. This is your node foreman. The kubelet's job is taking requests directly from the API server and making sure things get done locally. Next up, the container engine, like Docker for instance. This is the heavy machinery doing the actual creation of the containers based on the foreman's orders. And lastly, kube proxy. You can think of this as the internal mail and networking system. It makes sure all these moving parts can easily communicate with each other.
And finally, part 5, deployment workflow.
So we've met the whole team, right? We know the product, the managers, and the workers. But how do they actually build a pod together? Let's watch this entire factory system in action. From the exact moment a user places an order, how does a pod go from just a request to a living, breathing application? Let's watch this build step by step. Step 1, a user requests a deployment. They hand this over to the receptionist, the API server, who checks their credentials. Moving to step 2, the API server creates the initial pod wrapper, basically getting the box ready. Step 3, the allocator, our kube scheduler, scans the factory floor, checks resources, and finds the absolute healthiest worker node for the job.
Down to step 4, the API server radios the node foreman, the kubelet, who throws the switch and commands the Docker machinery to spin up the container. And finally, step 5, the kubelet radios back, job done, and the API server updates the etc record book so the entire company knows the new pod is live. Boom, done.
Now, one thing to remember here. To keep things secure and orderly, only our front desk receptionist, the API server, is allowed to write in that etcd company record book. No other component, whether it's a worker on the floor or another manager, can access the etcd database directly. Every single thing must funnel through the API server. This strict hierarchy ensures our factory's data is never corrupted or out of sync. Actually, this is exactly how massive enterprise applications prevent chaotic data collisions when millions of users are making requests all at once.
As we wrap up this explainer, I'm going to leave you with this critical thought. We know the factory halts entirely if management disappears, right? So how do real-world systems keep these supervisors alive? If the master node is a single point of failure, enterprise architectures absolutely must have a way to build in redundancy and backup managers. So how would you design a backup for this control plane? It's a fantastic question to ponder as you continue to explore container orchestration. Thanks for joining me on the factory floor today.